Okay, we're going to be working on electric circuits F. This is going to be number 5. All right, what we need to do is fill in the ammeters and the voltmeters that are in this circuit. All right, anything that is in parallel with a resistor is going to be a voltmeter, along with the meter that's right in front of the power supply. So anything that's not, it looks like it breaks a wire, is going to be an ammeter. So when we do this one, we're going to use the equation V equals IR all the time in different forms. So first thing I want to do is look for where do I have 2 of the 3 variables in V equals IR. First place I find it is going to be right here at the end where I have the 2.5 voltmeter and a 10 ohm resistor. So if I want the current that's going through this resistor, all I do is I take I equals V over R, which is going to be 2.50 volts over 10.0 ohms. And from that I get 0.25 amps. All right? So this is going to be 0.25 amps. So the current that goes through that resistor is also going to be the current that goes through this meter here at the bottom that it returns to the power supply. So that is going to be 0.25 amps. Now I know I have a total of 0.25 amps in the circuit. Well, there's something else I know about this, and that is the total voltage is 7.5 volts. All right, so if I want the voltage in the parallel part of the circuit, remember whatever voltage is supplied, 7.50 volts, if I subtract off the voltage that the electron encounters as it goes across the resistors as I go through the circuit, which is going to be 1.25, it also encounters the resistor at the end, which is 2.5 volts. And it encounters the resistors in the parallel circuit. Now an individual electron will only encounter one of these resistors. So I basically have an unknown resistor, and that should cancel out to 0, right? Whatever voltage supplied should equal voltage used in the circuit. So what I have here, 7.5 volts minus 2.5 volts leaves me with 5. Subtract off another 1.25 volts, that leaves me with 3.75 volts. Whatever voltage is in the top part of the parallel circuit is the same in the bottom part of the parallel circuit. So I know those voltages. I know this current here at the end, which means I also know this current here. Whatever returns to the power supply also originates at the power supply. So if I want to find this resistance here at the beginning, R equals V over I, which is going to be equal to 1.25 volts over 0.25 amps. And that leaves me with 5 ohms there. Now, let's go back and let's see. I still have 2 more ammeters to get. These 2 ammeters, I can get the one on the top because I have both the resistance and the voltage there. So I equals V over R. The voltage across the resistor in the top leg of the parallel circuit is going to be 3.75 volts. Divide that by the resistance, which is 30 ohms. So my current on this one is going to be 0.125 amps. Now this is one of these kind of interesting circuits because if you notice the total current is 0.25 amps and the top leg it's 0.125 amps, which means how much goes to the bottom leg? Because whatever current comes in splits going up and down. It does not have to split evenly. All right, but in this case it turns out it does because 0.25 minus 0.125 gives me 0.125 here. So now to figure out this resistance, it's just going to be 3.75 divided by 1.25, which turns out to be 30 ohms. And that one's done.